Okay, so yesterday we learned how to solve a quadratic equation using method 1, which was factoring. And most of the factoring requires decomposition. But if it does not require decomposition, I wouldn't waste my time doing that. So today we're just going to look at a different method for solving quadratic equations. So I'm asking for the same information. I'm still asking for an x root, a y root, the vertex, and graphing the quadratic function. I also want you to state the axis of symmetry, domain, and range. Like, it's a loaded question. There's a lot going on here. So we're just going to start by solving the equation negative 3x squared plus 2x plus 1 by completing the square. So in order to complete the square, I'm just going to rewrite the equation. We know that we're not allowed to have an a value. And in this case, since a is equal to negative 3, we need to factor that out. Only for the first two terms though. So we're going to factor out that negative 3 for the first two terms. So we have x squared. And then don't forget that a negative divided by a positive gives you a negative. So negative 2 over 3x. And then we just rewrite the plus 1. So at this point now you can start completing the square using the methods that we've learned in class. We take the b value, which is negative 2 over 3, and we divide that by 2. So we know that when we're dividing fractions, we want to put both as fractions. And instead of dividing, we're actually going to multiply by 1 over 2. So this gives us negative 2 over 6. Please make sure that you're reducing your fractions at all times. So I'd like for you to make sure that you divide this here, this fraction, by 2. So this gives you negative 1 over 3. Now don't forget that dividing by 2 is not the only step. You have to take this number and square it. And the whole purpose of doing that is so that you can actually create a perfect square. So I'm going to go ahead and create that perfect square right here. Just going to use a different color to show you. So it's going to be x squared, minus 2 over 3x, and then it's going to be plus 1 over 9. And then if we add 1 over 9, we have to make sure that we're subtracting 1 over 9 as well. And that has to stay inside the bracket, okay? A perfect square trinomial is the one that I wrote in green right here. So we need to find a number that multiplies to positive 1 over 9, but adds up to negative 2 over 3. And that number is negative 1 over 3. It's right here. So we're just going to factor that as x minus 1 over 3 squared. And then don't forget that when you take that out, you have to also multiply negative 3 by negative 1 over 9. And be careful when you're multiplying fractions. We're going to put this over 1. Negative 3 times negative 1 is positive 3. And then it's 1 times 9, which is 9. So this is a crucial step. If you forget to multiply the negative 3 by negative 1 over 9, it's going to screw up this whole thing. So now that we have our perfect square, we've completed the square. From here, the whole point of completing the square is to go from standard form, which is this one. Okay, so standard form, if you guys remember, is ax squared plus bx plus c equals 0. And we want to complete the square for this to be in vertex form. And we've talked about vertex form before. It's a bracket x minus h squared plus k. So that means that we can label the vertex from this equation right here. Okay? But that'll be in our concluding statement. So you can start that right now if you want. I'll start it right down here. Therefore, the vertex is, and if I go back up, the vertex is actually going to be positive 1 over 3. And, oh, I think I forgot something in here. I forgot the plus 1. Sorry, that happens. So we're just going to put the plus 1 over here. And I'm going to go ahead and put the plus 1 down here. And that means that I'm not quite done. I have to continue adding these fractions at the end. So I have to do 3 over 9 plus 1 over 1. So we have to get a common denominator. Just going to rewrite the rest here. Now that'll be 3 over 9. Plus 9 over 9, and all that's going to equal to 0. So we'll write that down over here. Okay. And then when we go ahead and we simplify this, we're going to get 3 plus 9, which is 12, over 9. Now every time you have a fraction, you have to make sure that your fraction doesn't reduce. In this case, it actually does. I can divide both 12 and 9 by 3, which gives me 4 over 3. So that was just a minor mistake. That can happen to you, so just be very, very careful. At the very end, you have to make sure that you add your constant. So in this case, it was the plus 1, which requires a common denominator. So this part here at the end is actually vertex form. So I'm just going to move what we wrote up here, and we're going to move it right down here. Okay. So vertex form is the h and the k. So the vertex ends up being positive 1 over 3. Remember that that has to be the opposite. And positive 4 over 3. Okay. So now that we have the vertex, I'm just going to go up and put a little check mark on vertex since I have that part. Now, we can also find some pieces of information, one piece of information from the original standard form. And the only piece of information that we can find from being in standard form is the y-intercept. And if you remember carefully, the y-intercept is your c value. So if you're looking at this right here, ax squared plus bx plus c, it's always the c value. So in this case, the y-intercept is equal to 1. So I'm just going to write that. The y root is, and don't forget that I want it in coordinate form, so it's actually 0, 1. That's pretty much all I can say right now. Standard form y-intercept, vertex form is the vertex. So now we have to find the x roots, and we have to graph it, state the axis of symmetry, domain and range. Well, since we already stated the vertex, we can actually state the axis of symmetry in our concluding statement. So the axis of symmetry is an equation. It's an equation that has an x equals, and it's just the x value from your vertex. That's all it is, because that's where it's going to be symmetrical if you fold the parabola in two. So the hardest part here is actually finding the roots. To find the roots, you have to solve the equation that you've completed the square for. Since it's already done over here, what we're going to do is we're going to start solving for x. So normally when there's a squared, we don't normally do that. But if it's already in completing the square form, in vertex form, then you're able to start solving for x. So I'm just going to write that down right here. Solve for x. And we're going to use inverse operations to do that. So the first thing we're going to get rid of is this positive 4 over 3. So we're going to subtract 4 over 3 on each side. So I'm going to be left with all of this and negative 4 over 3 on the right side. The next thing you want to do is cancel out the multiplication by negative 3, which means I'm going to divide both sides by negative 3. That's going to cancel that out, but it's not going to cancel it out on the right side. Remember again, when we divide fractions, we actually multiply by the reciprocal. Keep the negative at the top. So this becomes x minus 1 over 3 squared, positive 3 over 4. At this point here, we need to get rid of the square. So it's very, very procedural. If you do one of these steps in the wrong step, then you're going to make a mistake, and it's going to change all your numbers. So you have to get rid of the constant first, and then you get rid of the number in front. At that point, you can do the square root of both sides. But don't forget that when you do the square root, and a lot of you guys do forget this, you have to put a plus and a minus in front. Very, very important to put a plus and a minus in front because it needs to give us two answers. Remember that a square will cancel out a square root, so that's why we're left with just x minus 1 over 3. So at this point, we're going to split it up into two different equations. We're going to have x minus 1 over 3 equals positive 4 over 3. And we're going to have x minus 1 over 3 equals negative 4 over 3. That's why you need the plus and the minus. So then we can just solve, because it's a linear equation. We're going to add 1 over 3 over here. So if we add 4 over 3 and 1 over 3, it gives us 5 over 3. And then over here, we're going to do the same thing, but you just have to be careful, because this one's negative 4. So we end up with negative 3 over 3, which simplifies to negative 1. So at this point, those are your roots. Those are the roots that we found by completing the square and using inverse operations. You may want to review this and just kind of review this video, pause and redo it in order for you to really understand that step. So I'm going to go ahead over here and write down that the x roots are positive 5 over 3. Don't forget that when it's a root, the y value is 0. And it's also negative 1, 0. So those are the x roots. If I go back up, I've got the x roots, the y root, the vertex. I've got the axis of symmetry. And I'm just going to wait for domain and range because I find it easier to graph. So we're going to go ahead and make a graph here. I want to see how you want to scale your graph based on the information that you have. Now, the vertex is sitting at 1 over 3 and 4 over 3. And that just means that if you divide the top number, 1 divided by 3, it'll be 0.3. And 4 divided by 3 will be 1.3. So you just want to make sure that you're scaling your graph appropriately so that this works for where you're putting the axes. So I know that the x roots are 5 divided by 3, and if I do 5 divided by 3, it gives me 1.666, so it's actually 1.7. So I'm going to go to 1.7, and I'm actually going to scale this by 0.5s. I think it'll make it just a bit more clear. So I'm going to go ahead and just scale this to give it a little bit more room. You can scale it however you want. I just find by 1s or by 0.5s, if the numbers are small, is more beneficial. So let's go ahead and put the x root of 5 divided by 3 at positive 1.7, which is approximately right here. And we'll put the other one at negative 1, 0. We're going to label them. So negative 5 over 3, 0, and negative 1, 0. We're going to go ahead and put the vertex at 0.3 and about 1.3. So right about here. Okay. That's the vertex. Sorry, the vertex is 1 over 3 and 5 over 3. And then we have a y-intercept. The y root is 0, negative 1, or 0, 1, sorry. 0, 1 is right over here. This does not look like a parabola. It's because I put my dot at 0 and 0.5. So I totally screwed that up. Hold on, that just took away my whole... Okay. Okay, so the dot is supposed to be right up here. Okay. Drawing my line, it's not quite on the axes, so just kind of try to picture it being on the line. So if I draw this parabola, it will look like a U-shaped curve, just like this. So don't forget to label your y root, which is 0, 1. So the graph is kind of messy, okay, but it is what it is when you have to label all this work on your graph. Don't forget to label what it is as well. Okay, so there's an x root and there's an x root as well. There's plenty of room to be able to organize your work properly. So let's make sure that we have all the information. I checked off x root, y root, vertex. We did the graph. We stated the axis of symmetry. Now it's just domain and range. So domain of any quadratic equation, any parabola will be x element of real numbers. That means that all possible values for x are possible. And then the range in this case, because it has a maximum, it's all elements of real numbers such that y has to be less than or equal to the y value of your vertex, which is 5 over 3. Okay, and this is all the information that is needed, all of it. So again, if you want to review this, I suggest going to OneNote and copying the link. I did this fairly quickly, but it's important for you to review